Today we're going to solve trig equations 5.3 day 1, work on examples 1 through 5. First equation is 2 sine x minus 1 equals 0. So I want to get sine x by itself, so the first step is to add 1. We get 2 sine x equals 1. And if I divide by 2, I get sine x equals to 1/2. Okay, our job is to try to figure out where the sine of x is equal to 1/2 without using the arcsine function on a calculator. Okay, so sine of x equal to 1/2, since it's positive, I know it's in either quadrant 1 or 2 because it's positive. And so therefore it's actually in both. Draw me a triangle. I know sine means opposite 1, hypotenuse 2, which means this is a square root of 3 down here, which indicates the fact that this is a 30, 60, 90 triangle, with the fact that this is the angle opposite 1, we know it's 30 degrees. And we know 30 degrees is pi over 6 in the first quadrant, and in the second quadrant, it is 5 pi over 6. So there's the answers, 5 pi over 6 and 5 pi over 6. At least initially those are the two answers. We know that sine of 1/2, we can generate this in the first or second quadrant, but we also know that if this is the first quadrant angle, if I go around the whole thing again, it's another answer. If I go around the whole thing again, that's a third and fourth and fifth answer, and so on and so forth. So to accommodate for this, I'll take pi over 6, going around the circle one full time is adding 2 pi. So I'm going to go plus 2 n pi, where n represents number of times around the circle. Number of times around the circle. Okay, so it basically means this shows an infinite amount of solutions. I'll do the same thing for the second quadrant angle of 5 pi 6, and I'll also add 2 n pi. Another way to think about adding 2 n pi is just because sine repeats itself every 2 pi units, or because 2 pi was the cycle or the period when we graphed it. So it repeats itself every 2 pi. We just use n to indicate that it can go on forever and ever and ever. So here's the answer on example number 1. Just a little extra on why 5 pi 6 is the other answer. If I were to draw this in the second quadrant, the reference angle would be here, and it's 1, 2, square root of 3. So this is a pi over 6. And if I took, since this is pi out here to the side, it'd be pi minus pi over 6, which is 5 pi over 6. That's a little more where 5 pi over 6 came from. So the final answer is what we circled right down here. Go ahead and see if you can figure out number 29. Press pause if you need some help. Okay, so you've pressed pause, you had a chance to work out 29. Hopefully by now you've subtracted 1 to get 2 sine x equals negative 1/2. Sorry, get equals negative 1. If you divide by 2, you get sine x equals negative 1/2. This is similar to number 1, but it's different. Sine is negative in quadrants 3 and 4. Okay? So if I draw a triangle, doesn't matter what the triangle looks like. Angles here, opposite is 1, hypotenuse 2. That means this is a 30, 60, 90, with this being a 30-degree angle. And so pi over 6. So we need pi over 6 in the third and fourth quadrant. Well, pi over 6 in the third and fourth quadrant, this is the angle in the third, so that's 7 pi over 6. And then the angle here in the fourth, this would be 11 pi over 6. Or essentially subtract pi over 6 from 2 pi, add pi over 6 to pi, like that. Okay? Now, in these directions, it says given over the period from 0 to 2 pi, meaning that this limits our answers to only things that are in the first, second, third, and fourth quadrant, meaning it won't be like the example number 1 because it's not an infinity thing. It is between these, this is the range of our answers. And so 7 pi over 6 and 11 pi 6 are the two answers because they fit within the range 0 to 2 pi. Let's move on to example number 2, collecting like terms. Again, solving an equation. I notice that I need to add sine of x to both sides. Add sine of x to get 2 sine of x plus the square root of 2 equals 0. Then I'm going to subtract the square root of 2. Then I'm going to divide by 2. And I get sine of x equals square root of 2 over 2. And again, this one over here in the direction said for over the interval 0 to 2 pi. So I'm just looking for answers in the third and fourth quadrant. I know it's 3 and 4 because the sign is negative in 3 and 4. Alright, so what I like to do is draw a little triangle or a big triangle, depending on your perspective, I guess. Here's my angle x. Opposite is square root 2, hypotenuse is 2. What could this other side actually be? Well, if it turns out square root of 2 squared plus b squared equals 4, because 2 squared, or just call it 2 squared. So 2 plus b squared equals 4, b squared is 2, b equals the square root of 2. So it looks like, since these two sides match each other, that this is a 45-degree angle, which is the same as pi over 4. So now I need pi over 4 in the third and fourth quadrant. Well, pi over 4 in the third will be right there, so add pi over pi plus pi over 4, and that's 5 pi over 4. Pi over 4 in the fourth is down here, so take 2 pi minus pi over 4, and that's 7 pi over 4. Again, since this has given the answers must be between 0 and 2 pi, I don't use the 2n pi thing, I just go with that with my answer. See if you figure out number 37. 37 has no darn it. 37 has no range or limit to your answer, so you're going to have to do something that's extra on this one. Okay. Actually, that's not true. That's also from 0 to 2 pi. Excuse me. I got to read the directions more clearly. So, first thing here, subtract square root of negative square root of 3. So tangent of x equals negative square root of 3. Draw a triangle. There's x. Tangent means opposite over adjacent. Well, 1 square root of 3, it means this is a 2. Opposite the square root of 3 is a 60-degree angle, which is pi over 3. Okay? Tangent is negative. Tangent is negative in quadrants 2 and 4. So I need pi over 3 in the second and fourth quadrant. So that's going to be 4 pi over 3. No, excuse me, that's not right. The second quadrant is the 2 pi over 3. So I take pi minus pi over 3. The fourth quadrant is going to be 2 pi minus pi over 3. And that's 5 pi over 3. So our answers are 2 pi over 3 and 5 pi over 3. Moving on to example number 3. Notice on example 3, it says over the interval from 0 to pi. So that's only in quadrant 1 and 2. Well, first thing I'm going to do is add 1. 3 tangent squared x equals 1. Divide by 3. Because it's squared, I now have to take the square root of both sides. And I get tangent of x equals the square root of 1/3. Well, the square root of 1/3 is 1 over the square root of 3, which equals 3 over square root of 3. But sometimes it's easier to find the angle if you just leave it as 1 over the square root of 3. So if I draw a triangle, x right there, opposite 1, square root of 3 is the hypotenuse. or sorry, the adjacent side, which means this is another 30, 60, 90, which means x is 30 degrees, which is pi over 6. Okay? But one thing we have to realize is that when it's the square root of 1/3, that makes it plus or minus. Therefore, I need an answer in, because it says 0 to pi, I need an answer in the first and second quadrant, because the positive one's in the first, the negative answer's in the second. So pi over 6 is one of my answers. Then I have to find pi over 6 in the second. To find pi over 6 in the second, I take pi minus pi over 6, and I get 5 pi over 6. So the answer is pi over 6 and 5 pi over 6 on example number 3. Okay? I want you guys to go ahead and try number 39. Notice the range of answers is 0 to 2 pi. Press pause, try to figure it out, then come back. Okay, first step, as you figured out, was to add 2 to both sides. Then you square root the whole thing. You get the cosecant of x equals plus or minus the square root of 2. Cosecant is positive in the first and the second. Cosecant is negative in the third and the fourth. So I need an answer. I need 4 answers. I need an answer in all 4 quadrants. For square root of 2, cosecant is hypotenuse over opposite. And so that makes this a 1, 1 square root of 2 triangle, which means x is 45 degrees, which is pi over 4. Pi over 4 is my first quadrant angle. To find the second quadrant angle, I'll take pi minus pi over 4, and that'll give me 3 pi over 4. To find the third quadrant angle, I take pi plus pi over 4, and that'll be 5 pi over 4. To find the fourth quadrant angle, I take 2 pi minus pi over 4, and that's going to be 7 pi over 4. Those are my 4 answers, 1 for each quadrant on number 39. Okay? Let's go ahead and move on to example number 4. It's getting a little bit more complicated each time. But what I notice about example 4 is the first thing I'm going to want to do is subtract 2 cotangent x. To get cotangent x, cosine squared x minus 2 cotangent x equals 0. It looks like I should factor out a common factor of cotangent x. That'll leave me with cosine squared x minus 2 equals 0. Now that it's been factored, I'm going to set my factors equal to 0. So cotangent of x equals 0. Cosine squared x minus 2 equals 0. Cosine squared x equals 2. Square root both sides. Cosine of x equals plus or minus the square root of 2. Okay? Well, for cosine, we know it is adjacent over hypotenuse. And here we have a problem. The adjacent side cannot be bigger than a hypotenuse ever. Therefore, this one is a no solution for that part of it. Does not ring any bells. It's false. It's completely false. Doesn't work. How about cotangent of x equals 0? Well, cotangent of x equals 0. If we recall cotangent, if it's equal to 0, we gotta go to quadrantal angles. And we go 0, 1, 1, 0, negative 1, 0. We know cotangent of x is x over y. So so that means it has to be pi over 2 is the answer. Well, notice this does not give you any limits on your answers. It doesn't say 0 to pi, doesn't say 0 to pi. But I know that cotangent repeats itself every pi units. Therefore, it's going to be pi over 2 plus n pi. Notice on sine and cosine we used 2n pi earlier in this lesson. But since cotangent of x repeats itself every pi units, its period is pi. I don't use the 2, I just use n pi. I know it's a little bit confusing. As we get more experience with it, it won't be quite as bad. We'll talk about it some more in class. Go ahead and try number 41. Lucky for us, again, it says anywhere from 0 to 2 pi. First step is to subtract cosine x. Now I'm going to factor out a cosine of x, leave me with cosine squared x minus 1 equals 0. So cosine of x equals 0. Cosine squared of x minus 1 is 0. Add 1 to both sides. Square root both sides. Cosine of x equals this plus or minus 1. Alright, so this looks like 0, this looks like 1. I'm going to draw my quadrantal stuff here. 0, comma 1, 1, comma 0, negative 1, comma 0, and 0, comma negative 1. Cosine is x. Where's x 0? X is 0 here at pi over 2. X is 0 here at 3 pi over 2. So there's two answers. And then cosine of x is equal to positive or negative 1. Well, the cosine of x is equal to positive 1 since cosine is x right there, so 0. Negative 1 right there at pi. But it's also here at 2 pi, it's positive 1, but I don't use 2 pi because in my directions it says bracket for 0, which means 0 is included, parenthesis at the 2 pi, which means 2 pi is not included. So I have my four answers of pi over 2, 3 pi over 2, 0, and pi. Let's go ahead and move on forth to example 5, last example for this lesson. This looks like a factoring job. Let's go ahead and draw a little line down the middle. If I replace sine squared with x squared and sine of x with x, I'm left with that. We recall, or hopefully we should, the factoring we took a times c, which is 2 times negative 1 to get negative 2. We factored this to negative 2 times 1 because they multiply to make, sorry, that's not quite right. Okay, a times c, we multiplied negative 2 times 1 to make negative 2 and added that to make negative 1 in the middle. We divide by a, which is 2, negative 2 to get negative 1. And so this factors to x minus 1 and 2x plus 1. Something you should remember. Now come over here and change the x's into sine x. And now you have sine x minus 1 and 2 sine x plus 1 equals 0. Set my factors equal to 0 and solve. I'm going to subtract 1 and divide by 2 all in one step here because by now you're advanced enough to do that. Sine of x is equal to 1. Well, we already said that was going to be at sine is y. So 0 comma 1, that's going to be pi over 2. And then the sine of x equal to negative 1/2. First thing we know is it's quadrant 3 and 4. Draw my triangle because I like to draw triangles. There's x, opposite 1, hypotenuse 2. We know that's pi over 6 because it's 30 degrees. But it's going to be quadrant 3 and 4. So for this, I'm going to take pi and add it to pi over 6 to get 5 pi over 6. Now I'll take 2 pi minus pi over 6 for my quadrant 4 and get 7 pi over 6. Wait, 7 pi is not quite right, is it? Sorry. That should be 11 pi over 6. Try that one more time. That should be 11 pi over 6. And if I add pi over 6, that should be 7 pi over 6. So there are the three answers that are going to be available on example number 5. Alright, last problem to try, number 49. That's going to factor into 2 sine x plus 1 and sine of x plus 1. If you need help factoring, let me know. Solve these by setting them equal to 0. 2 sine x plus 1 equals 0. So if I subtract 1 and divide by 2, I get sine x equal to negative 1/2. Sine of x is negative 1. Sine is y, so that's down here. So that's 3 pi over 2. Sine of x negative 1/2. Opposite 1, hypotenuse 2, so that's a pi over 6 angle. Quadrant 3 is 7 pi over 6. Quadrant 4 is 11 pi over 6. And so there are my three answers for that one.